Welcome to our lectures on the DC microgrid and the control system. Today we shall continue with the intelligent control, intelligent microgrid operation and control. We have talked about a fuzzy logic controller. Today we shall talk about another intelligent control for namely ANN and GA and other entities. So, broadly today this will be our content of our discussions, that is artificial neural networks. Artificial neural networks, students are requested to brush up their basics, because we cannot take all the whole courses on the ANN here, we just can touch, but we can show that how it can be applied in case of the microgrid AC as well as DC. Now, the genetic algorithm, same thing. So, it is a heuristic function. For any optimizations, genetic algorithm can be used. They have a multi agent system, that is a MAS, and the multi agent systems applications in the microgrid, because you have a different stakeholder, that is they have different kind of load, you got a different kind of source, you got a energy storage element. For this reason, that exactly fits to the multi agent system, and for this reason we shall show it how to deal with it in our applications. Now, what is ANN? ANN is basically inspired from our human brain applications or the animal brain applications. ANNs are, of course, it is artificial neural network, full form is that, are numerical model free estimators. When you know that input and output can be mapped, so you know how our brain works. It is very difficult to understand, because you try to understand my brain, but some portion of whatever function it is known to us, we try to emulate the same kind of application artificially, and thus it becomes an artificial neural network. So, we say that ANN are numerical model free estimators, because we do not know the model of our brain for this reason, but we know the input and output, and we know that it works, and thus same thing has been inspired. So, numerical model free estimators which can estimate how output functionally depends on the input without the need for the complex mathematical model. You know, if you are putting f x equal to x square, you can compute any data, but you know you have a data and you want to interpolate some data in between. There are different method of the interpolation, that is a mathematical model, and thus you got an error. But for example, our populations of India is counted every 10 years. If I wanted to know what is the population today, then we require to interpolate the data. So, for this reasons, you know, this interpolations can be a mathematical model, but instead of the mathematical model, when you have a large number of training set, it can constitute the input output relations without establishing explicitly the mathematical model. That is the advantage of it. So, you do not bother to know what exactly that mathematics, and thus it works. And ANN consists of a number of nonlinear computational processing elements. These are inspired from the human brain, for this reason it is called neurons, arranged in several layers including input layer. So, there are several layer, output layer, and in between there can be some layer, this is called the hidden layers in the in between. So, constitute of the ANN can have input, output, if it maps fine, otherwise if it cannot map, we require to put it some layer in between. Every layer contains one or more neurons. Neuron are the functional block of it, generally it is a weight or the gain, you can think of the op amp, then it is a gain, and the output of the each neuron usually fed all for the most of the input of the neurons in the next layer. So, this is the constitutor of the layer. We will come to the constructions of the neuron little bit later, maybe the next slides. The input layer receives the input signals, which are then transformed and propagated simultaneously to the network layer, through the network layer by layer. The neuron accepts one or more inputs. It can op-amp can takes the more, it is something like you visualize this thing as a gain element by op-amp. Op-amp can takes multiple input with the scaling, and first artificial network network was based on in analog domain, and it was based on op-amp only. So, one or more input signal produces one or more output, and so you require a little bit of scaling. That is something you do not know, because generally you have a single output in case of the op-amp, and which is a linear functions, which is that is something you have to think about it, because you know that gains are linear. So, nonlinear functions of the weighted sum of the inputs. So, it will do some kind of, so you have a inputs x 1, x 2, x 3, and ultimately it will have some kind of numerical functions. So, that numerical function not necessarily linear, this is on x 1, x 2, x 3, ultimately it will, x is a function, x is the inputs, and y will be the y, or y1, y2 can be the outputs, and that may have some kind of mathematical relation or may not have some kind of mathematical relation, can be explicitly put it into the terms of the mathematical functions. The mapping from the input variables to the output variable can be fixed by setting all the weight associated with the each neuron to some constant. So, we require to put some gains or some constant. So, that is what we go by. Now, one important aspect is that we require to train our ANN. So, someone has to tell I am Dr. Ravi Bhattacharya, otherwise it will not work. So, then your eye not recognize me as Dr. Ravi Bhattacharya. So, for this reason we require to have a training set. So, then what happen, you know for the given input for given output, and accordingly this weights of the ANN are being tuned to match input with the output. Once training is complete, then you give the test data where you have not given that data for the training, then also you know that your input and output. Once it is working extremely fine within the range of the acceptance of error, then this you put this model for your prediction purpose. That is the way it works. So, the training of an ANN in a control structure is a procedure to adjust these values, so that ANN can map all the input control values to the corresponding output control values. So, that is the way it start working. From the control configuration point of view, the most proposed ANN based on microgrid control design can be divided into the 3 general control structures. So, one can be rather directly using ANN system as a controller to provide the control command in the main feedback loop, which was we have shown previously. It is basically based on PI controller. Using ANN for tuning the parameters of existing fixed structures controller, that is also one of the way of employing ANN in microgrid application, that is using ANN for tuning parameter for existing fixed structure controller, that is the KPKI of the controller can be tuned very well with the help of ANN. That is the auxiliary application, and this PI controller itself can be replaced by the ANN controller, that is the first one directly using ANN. Using ANN system as an additional controller, which we have seen in case of the in case of the fuzzy logic controller, it is same thing. Additional controller in parallel with the existing conventional simple controllers such as PI or PID to improve the closed loop performance. Here what happen, it can reduce the overshoot, it can give you faster settling time. These are the few advantage of this model. So, this figure 1 shows the general control structure based on the NN. Now, you have input data and you have to back propagate the signal, that is called the back propagation algorithm. There are many algorithms to tune it nowadays. Simplest was the back propagation algorithm and you got an output. So, you have to train accordingly when input will match the output, the reverse, and thus you change the weight like that from output to input. So, thereafter you can have a second application, that is, you already have a PI controller and that is working fine, but this tuning of the PI controller you can take the help of the Nichols and all those methods, gain margin, phase margin. From there you can optimally design, but then also you find that taking also, because you have approximated the system as a nonlinear system, performance is not satisfactory. Then you require to tune it further, and their input output model can help, and you can help to tune the PI controller. There is plenty of papers for tuning PI controller by NN. That application can be directly applied in case of the DC microgrid, because it applies the PL control. Another aspect, of course, you have a PI controller and you have designed with the due considerations, still its performance can be improved. And then what you do here, essentially you put a extra NN controller that will essentially take an input and will add up some extra value of the Y, that will be the output of the PI controller, and that will give a optimal response of the total system in terms of the overall performance of the system. Because you know that essentially when you design an PI controller, everything zeroed down by the model reduction technique, or you may neglect the insignificant pole and zeros and all those things, and ultimately you require to bring down the system to the second order system, then only your linear control system works fine. And in that approximation process, you have neglected so many things, and ultimately you came down the value of Kp and Ki with a due mathematical consideration, or if it is a PID all. Then what happened, to take those nonlinearity which we have neglected in designing the PI has to be considered to the optimal design of the PI performance, and thus this ANN does not have any mathematical model, and you add with that, and this add on will definitely make the system to performance, give you better performance. That is the whole idea of using this kind of ANN. So, in the figure 1c, the 3 controller are significant controller configuration are presented, and it is been tuned with the backpropagation algorithm. This is the simplest algorithm. There are so many algorithms which you are researching on the NN, you can find so many papers on different kind of algorithm. There is a RLS algorithm, recursive least square algorithm. So, it has its own advantage. So, if it generally it involves the inverse of matrix, if you can inverse of if you can avoid the operation of tuning NN with the without help of the inversion of the matrix, your tuning will be faster. So, while you are tuning online, sometime it is required adaptive, it is called adaptive neuron, that is called Adaline. So, there are a different kind of algorithm if you wish to work on the ANN. So, and so you require to read the basic papers and the basic applications of the ANN. So, backpropagation, which gradient descent learning algorithm. So, but it has a problem that it may converts to the local media minima, is a gradient descent learning algorithm in one of the most popular supervised learning algorithm in all the mentioned configuration. And back propagation algorithm is generalized as a generally it will reduce the mean square error. So, for this it is called the least mean square or LMS procedure for the feed forward multi-layer network with the hidden layers. So, that is called the LMS algorithm, and it uses the gradient descent technique. So, you have a different kind of this is a curve, let us say, but it has a problem that it will start from here, it will be converging here, it may not converge here, and it may converge to the local optimal point, whether you are seeking the maximum or minimum. But if it is here, if you are trying to find the global maxima, it will give you a global maximum, saying it is a closure. So, which changes with the weight between the neurons in its original and the simplest form by an amount of the proportional to the partial derivative of the error function with respect to the given weight. So, this is the way it will work, and it will try to converge the nearest optimal point from the point of starting from. This the starting point is very important. If the starting point, it may not reach the global optimal point. As shown in the figure 1b, please go back. So, this is the figure. So, here you have a ANN, and you are tuning this parameters of the PI controller by ANN. ANN perform as a automatic tuner. It is basically the tuner of the PI controller. The initial values of the parameters of the fixed structures of the controller Kp and Ki of the PI must be defined, and it should be close to this optimal point. Otherwise, it may lead to some other point and you get a worse result. So, for this reason we require to be very cautious, because you have to bring very close to this optimal point, then only it can bring it to your destination. So, the ANN collects information about the system response and the recommends adjustment, that is a weight generally, to be made in case of the PI controller gains, that is the Kp Ki, or if it is a PID controller, then Kp Ki and Kd. This iterative procedure until the fastest possible critical damping for the control system is achieved. So, we want ultimately this, we have a knowledge of the time response of the second order system, and we want that the system should be just below critically damped. So, that kind of response, so overshoot is very low and it has a faster response. So, all those optimality has to be considered, and accordingly PI to be designed, and that tuning can give you that optimality. The main component of the PI the ANN tuner include the response recognition unit to monitor the control response and extract the knowledge about the performance of the current controller gain setting, and embedded unit to suggest suitable change to be made into the controller gain. So, that is something we require to know very well. So, they include the response, that is basically the time response of this PI controller, that behavior should be known to you, and accordingly you start tuning online mostly. And so, please remember that this PI controller, if it is employed into the current loop, it has to be extremely fast, and for this reason we have to have a performance of the current controller gain has to be tuned for the optimal purpose. Now, as we have discussed the ANN has a problem of this backpropagation algorithm. This is gradient based, and thus it cannot find the global minima, and it may has a tendency to localize, or it may highly it will be depending on the initial value. If it is the initial value is close to the global maxima or minima, then it will converge to it. If it is not, it will take you for the further point. And to overcome this this difficulty, we have the heuristic method. There are many heuristic method, and this is one of the heuristic popular heuristic method, that is called the genetic algorithm, and that also inspired from our human evolution system. It has been assumed that we are smarter than our parents because of process of evolution. One may doubt it anyway, that is a different issue, but we have a generating algorithm. So, you got a initial populations, and that these are called generally the genes. Then you will test for this evolution, that is the Darwinian principle, survival of fittest. Whosoever fits best, then those genes will be asked to go to the next stage, and that is called the fitness evolutions. So, in terms of the Darwinian evolution theory, it is survival of fittest or the process of the natural selections. So, that is called the fitness evolution. So, thus you got a selections of the genes, and in between they will have a crossover and mutations. So, they will, like please go back to our biology which we have studied in our school days, if we have not studied biology in higher in college days. So, we have a mitosis. In mitosis, cell divisions generally that is a different kind of cell division, and they have a meiosis cell division. Mostly this is for the our reproductive system, and there we will have a crossover and the mutations. So, this crossover and mutation, some portions of the chromosome will, and let us say this one is X1 and this one is X2. So, this portion may come here. So, it is actually the hybrid X2, and thus you have a crossover, and you can give a crossover ratio in the programming. So, you can have a 20% gene from it will come over here and vice versa. So, that is a crossover. Then you give a probabilistic, in program you give a probabilistic thing. So, among these genes you give some portion of the mutation. So, some of the genes in between the chromosome will abruptly change, and thus new value will come, and in that way you will actually have a next generations. And in next generations again you will go to the same fitness evolution, selections, crossover, mutation, and this loop will continue till you got an error that is prescribed less than the value you wanted. So, that is the optimal generations point, and thus you got an optimal power. It has many advantages, though this tuning is slow because it takes lot of iterative loop, and it depends on the crossover and mutations ratio how you are working on it, but it generally picks up the global minima, but there is a problem. So, generally if it is a global minima and if it is here, it may jumps to the crossover at this point. Again you got a crossover, it may comes to this point, and it may actually not reach here and ultimately continue to do the oscillation. So, this is one of the major disadvantage of it. So, but once you working on it, you will be more familiar to actually damp out these oscillations also. So, let us talk about the GI here. The GI mechanism is inspired by the mechanism of the natural selections, where stronger individual will be likely to be winners of the competing the environment. Please understand that evolution function to be fit accordingly. If you set a particular fitness function to taking a log from the forest, of course elephant will win the race. And definitely if you set another milestone or to taking a lock into the to the foothills of the some mountains, then of course donkey will win the race. So, for the purpose of your requirement, you will fit the evaluations, fitness of evaluation, and thus different chromosome will satisfy the different need, and ultimately you will have a optimal need. The normally the GA in a GA, the parameters to the to be optimized are represented in a binary string. These are called mostly chromosomes. It is inspired from the biological system. A simplified flowchart of the GA has been shown in this figure. Now, so these are the few entities that you require to familiar while writing program in GA. The cost function, which determines the optimization problem, represents the main link between the problem at hand and the GA unit. To start the optimizations, the GA uses the randomly produced initial solution created by the random number generator. That entity is there in the MATLAB. So, you can generate the MATLAB in a MATLAB code that random numbers, and there basically the 3 genetic operator used to produce a new generation. So, you require to some kind of samples, and that required to be tested for the fitness, and that produces a new generation. These operators are the selections, crossover and mutations. First you go for the selections and they come into the next stage, then you make this, then whatever genes are available, those who are already fitted, you crossover among themselves, there you give a probability of mutations, and then again you generate the next generations and test it. GA employs these operator to converge at a global optimal point. That is one of the main features of the GA, and after randomly generating the initial populations, GA uses the genetic operator to achieve the new set of solution in each iteration, and thus the GA is one of the rapidly emerging optimization approaches in the field of the control genetic algorithm system design, and application of the GA control systems are definitely the optimal and adaptive control, active noise control, and multi-objective control, because you want that multi-objectivity, your overshoot should be low, your response should be fast. So, these are conflicting features we require to incorporate in your system, and thus you want that some extent a optimal solution. Like you have a money, you want to have a liquidity to be high, your return should be high, risk should be low, these are all conflictings. So, for this it is called the multi-objective. So, we can have a solution, optimal solution based on our requirement, and thus robust tuning of the control systems by seeking the optimal performance indexes is provided by the robust control theorem and using the fuzzy logic and ANN based control system. So, this is also where you can apply your GA based control system. So, a simple GA based control system is shown in the figure 3. You can see that the GA controller consists of the 3 components: the performance evaluator, learning algorithm, and the control procedure. So, you got a reference. So, this is a performance evaluator, essentially it is a natural selections. Thereafter GA learning algorithm. So, you will tune the GA. So, and thereafter action producer, that is a point of signals, and you have a feedbacks, and accordingly your performance evaluator will change, that 5% of the overshoot you apply initially for the fitness. Gradually you take that, actually it is a 2% of the overshoot. Same way settling time, first you take some maybe 100 millisecond, then you come down to the 15 millisecond. So, gradually you may, from the sensors you can actually also fine tune your evaluations. So, that is also possible, and thus you get a set point control signals. Because if you set a very stringent evaluation and you may not get the very good number of samples to be survived. For this reason, you have to gradually change the performance evaluator to get it to the right kind of sample, and thus you got a data, your optimization function in GA, and you got a control output based on GA. So, figure 3 describes the GA based control, and one is GA main controller, and this is basically, this mechanism is the second one, that is as we have shown in figure 1b, that is tuning of the PI controller by GA. So, this is a way to you can use to control, this is a way you can tune the parameters of the PI controller by GA. These are the many paper based on that PI controller based on GA for optimal system design. Thank you for your attention. We shall continue with our some portion of GA as well as the multi objective function in our next class.